In this section, we will learn about how to find the value of x when you are specified the value of y. So let's go to this equation. Okay, this is the equation y equals negative 2x squared plus 9x minus 9. And when you graph it, this is the graph. So it is a parabola facing up downward. And you can see that this is the vertex and this is the x-intercepts and this is the y-intercept. So the first thing that we can get easily, if either it's visible from the graph or it is derived from the equations, is the y-intercept. The y-intercept is 0, comma, negative 9. Negative 9 from the c, and if you see it from your graph, it is visibly seen, it's clearly exactly at that point, right? So the next thing that we are trying to find is the vertex. If you see the graph itself, the vertex is not accurately on integers, of course, at integers coordinate. So we need to find it, right? So because based on the graph, we just cannot find the exact coordinate. So for this one, I will show you quickly using the vertex conversion into vertex form. So originally, this is the equation, right? Don't forget that the first thing that we do is add both sides by 9. Okay, and then since the a is negative 2, okay, it's let's just factor the right member, and then after that we complete the square. Since I'm adding something at on the left, on the right side, so I'm adding equally on the left member, but don't forget the left member will be this one multiplied by negative 2. And then after that, I just simplify both the left side, the left member, and then right member, I factor it. And therefore, based on this form, vertex form, the h is 9 over 2, the k is 9 over 8. So the vertex is this, or if I put in decimals, it is 2.25, so the x is 2.25, and the y is 1.125, which is makes sense based on the graph. Okay, that's for the vertex. And now, let me just remind you before we go to the x-intercept, for example, this function, actually, the y is a function of x. So actually, we can replace y by f of x. Okay, so f of x can replace y. F of x equals this. So when I'm trying to discuss what is the values of x when I specified a certain value of y, let's just use fx instead so we can be clear about the statement. For example, x-intercept. X-intercept, by definition, is the values of x if y equals 0. It means if fx equals 0, what is dx? Therefore, let me just replace that statement. So when the fx equals 0, 0, what is dx? Now, if this is the statement, you can directly use the discriminant, okay, as the tools to find whether we can factor it or not, or should we use the quadratic formula, right? Or we can really know what kind of x that we are finding. Is it two rationals, two imaginary numbers, two irrationals? So before we go further, let me check the discriminant by using the b squared minus 4ac, and this is the b squared minus 4ac, and it's 9. Don't forget, if the discriminant is 9, it means it is positive and it is a perfect square. Since it is positive and perfect square, we know that we are looking for two rational numbers for your x. Because it is two rational numbers, we can use either using the factoring or by using the quadratic formula. So but this one I will use the factoring. Okay, I will use the factoring. So this one I will factor it by the factor skill. This is the factor. Oh, sorry. This is the factor. Okay, this is the factor, and then I just go find the zeros. What are the values of x which makes each factor equal 0? So the first one is 3 over 2. The second one is 3. So therefore, we can see that, yeah, 3 over 2 or 1.5. This is the first x-intercept, and the second x-intercept is 3. Makes sense? And there you are. You get your x-intercept. So now the next question. The next question is this one. Okay. It means when the y is specified equals -5, what are the values of x? So if you see on the graph, when y equals -5, okay, the x, maybe if your graph is accurate, the first x equals, I think it's 0.5, and the other x is 4. So it's 4 comma -5 and 0.5 comma -5. So let's just check. Okay, so how if we find it by calculation? So this is the definition, right? uh, Sorry. And when fx equals -5, what are the x's? Now let me just go back to the equation, and then I replace fx by -5. Okay, remember that you cannot solve the quadratic function, or you cannot solve for x if we keep in this form. You need to make one member equals 0. So that is the first objective. For this part, I will convert the left member into 0. How? By add both sides by its additive inverse, 5. Okay, so that's the first step. Since I add both sides by 5, I will have this. So this is the starting point where you try to find the x's, the zeros, the roots. Okay, so at this state, of course, I will check again what kind of values of x that we are trying to find. By using the discriminant, okay, I will find that the discriminant equals 49. So it is also a positive and a perfect square. It means we are finding two rational numbers for the x. Therefore, I will use another factoring method for this case. So of course, keep in mind that you factor the last statement, right? Since you can do this after you make one member equals 0. So this is the factoring, and then I can find that the first x equals 1 over 2, since it makes one factor equals 0, and the second one is 4, because -4 plus 4 equals 0. Yeah, that is the values of x. Okay, sorry, I have to revise. So usually we are tend to just use 0 here, and that's wrong. Why? Because actually the value of y equals -5. That's why you have to be careful in putting the last statement. Okay, again, the value of x 0.5 and the value of x 4 are for y equals -5. Don't forget about that. So usually we are trying to rust and then make it 0. So that's difference, because 0 is the x-intercepts for y equals 0. So that is for answering this kind of question, but not this question. I hope it's clear. Okay, before we go to the next example, I want to revise that before, when we found it is 49, then we can conclude that the D discriminant is positive and a perfect square. It means we are finding two rational numbers of roots. So it's not necessarily x-intercept roots. Roots is the value of x that fulfill this statement. But it's not x-intercept, since the fx is not 0. We are the fx equals 5. Okay, so let me just give you another example. How about if we will try to find the value of x when the fx equals -8, or if the y equals -8. Let's see the graph here. When the y equals -8, the value of x, it is quite not visible or quite, yeah, we cannot just figure out the decimals here. Okay, so let's just find the value of it. So first, let me just remind you the equation. Okay, so let's try to substitute the fx by -8. Okay, and then we have to make one side or one member equal 0 to solve for x. It means let's add both sides by 8, and then this is the statement. From here, then we can find the value of x. First, I want to check the discriminant. I want to know what values of x that we are looking for. So by using this discriminant, okay, for this one, so the a is -2, the b is 9, and the c is -1. So the value of the discriminant is 73. It means it is a it is a positive, but it is not a perfect square. Since it is not a perfect square, it means we are looking for two irrational numbers of roots of the x. And it means we cannot use factor. We have to use quadratic formula. So let's use the quadratic formula to find the roots. So the x1, yeah, you can memorize the formula here. Don't forget that the a, b, c that we are using is from the last statement, from this one, right? Not this one. Okay. So after you put it everything and simplified everything, and this is the first x1. Okay, so this is the value of x when y equals -8. If you cannot use your calculator, for example, for the test and for the quiz, of course, this will be your final statement. But since I want to check to the graph, okay, what is the value of x when y equals -8? Let's find the approximated value of your decimals. When I use the calculator, I find this is my first value of x. And with the same method, I will use, I'm looking for the second x, and yeah, this is the final approximated decimals. So it is 0.0014, this one, and the second one is 8. Oh, sorry. If I made mistakes here, that's why I haven't. Now you look at that. If yeah, we need to cross check there and conclude that whether it is really reasonable or not. So actually it's not. So yeah, there you are. That's the correct one. So yeah, it is over 4. Don't forget. Yeah, it is 4 point. So this -8. It's 4.389, 386, and that's looking accurate. Yeah. Now this is the correct one. Therefore, we need to find. We need to put a statement. Okay, let me just write it down for you. Therefore, uh, if fx or if y equals -8, it means the value of x will be 0.0014, comma -8. This is the coordinates, and 4.386, comma -8. So those are the coordinates that satisfy your quadratic function when the y equals -8. And the last thing that I want to show you is what are the values of x when f(x) equals 2 or y equals 2. Okay, now let's see on the graph. When y equals 2, you can see that there is no values of f(x) since the graph itself is below that, right? So let's just pretend that we don't know the graph and we want to find the x. So how do you know whether they are the real values of x or not? So let's just do the same. We are referring to the same equation. So replace f(x) by 2, and then Don't forget, if you want to solve for x, you need to make one members equals 0. So for this one, I want to convert the left member equals 0. I subtract both sides by 2, and then this is my final statement. Then from this form, from this statement, I will look for the discriminant. The discriminant is negative 7. Since the discriminant is negative 7, it means the roots are two imaginary numbers, or there are no real values for your x. Yeah, that's answering your or responding to the graph. There is no values of x for the y equals 0, or for the y equals 10, or for the y equals 1000. There is no value. So you will find the same negative discriminant if you're using the y equals above the vertex. Okay, but again, if you are instructed to find the value in imaginary numbers, of course you can move forward by using the quadratic formula and then use ABC from the last statement, of course, since this is the one that you have already converted into 0 for one member. And don't forget that actually, since we have already found the D, you can directly replace the radicand here into the D. So you don't have to recalculate again. So just put negative 7 inside the radical sign, under the radical sign. So in the end, after you simplify it, this is the last statement of your first x in the imaginary numbers. And this is the second x value in imaginary number. Therefore, when or if fx equals 0 or if y equals 0, the values of the x are imaginary numbers like this. Or you can say that there are no real values for x, since on the graph itself speaks no real values. So it depends on the instruction. It depends on what is the objective. Do you really have to find, do you really must find the values of in imaginary numbers? Or you just try to check whether there are values of x, or if the graph still exists in some certain value of y. It depends on the objective. Okay, but I hope that you know how to use the discriminant, how to find the value of x when you specify the value of y.